In ancient history, creating software involved a lot of manual labor. We would invoke compilers by hand, run tar from the command line on a bunch of compilation products. Maybe more sophisticated engineers would handwire dependencies in a makefile, but that's still a lot of manual labor, as you can see. Eventually, the IDE came along and would offer an interface for the whole software development lifecycle, namely like editing, formatting, refactoring, building, running, testing, debugging, packaging, deploying, all from a single interface. Even a structure for organizing your code into projects and modules, all in one, all in front of you. I work on such an IDE, IntelliJ. On the IntelliJ Scala team, there's like 10 of us. By the way, I always like to ask who uses this fine product. Yeah, that's still most of you, great. And did you know our code is free open source on GitHub for the most part? Just raise your hand if you knew this. That's a few. Well, now all of you should raise your hand because you all know it now. So we do our best to fix bugs and improve the feature set, but if you're not happy, you're welcome to open a pull request or even just an issue. But that's just an aside. So this talk is about integrating developer experiences, namely in form of the build server protocol, which offers a way to integrate build tools specifically with IDEs. And I'll give an overview of the motivation and how it looks like and some specifics of the BSP implementation in IntelliJ. But let's take a step back. So we used to have these old school tools, and we have the IDE on the other hand, but a lot of us prefer to use one-job tools, so tools that work for a specific job like packaging, dependency management, testing, and so on. But we still want to have this all in our singular interface. At least I do. And my preferred interface isn't usually the command line. Your mileage may vary. But the command line is still very useful for offering a scriptable way of integrating these tools or running these tools so you can run them on your local machine, on a CI server, automated, whatever you like. So I prefer a unified interface for my coding. And so what we've had in the past is we try to integrate specific tools into the IDE. But as you can see here in this nice picture that creates a bit of a friction, a bit of a mismatch between tools. Like, what's this Roman-looking guy doing with this Egyptian statue here? They don't quite fit together that well, so it creates a lot of friction. But nonetheless, we have specific implementation listed here for Scala test specs in IntelliJ, for SBT in IntelliJ. And in the ultimate version, even specific frameworks like aka play. And we're not the only ones that have this problem. So I'm going to mention Bloop later, a build server that also integrates with a variety of build tools. And that too needs to implement integrations with specific build tools such as SBT, Mill, Maven, and so on. And yeah, build tools in Scala. We've got lots of choices. And yeah, as you may know, every few months or so, somebody comes up with a new build tool for the Scala ecosystem. But so I can't integrate all of these manually like we did with SBT. So you'll have various manual steps in the workflow. You switch between terminal and IDE to compile, to edit, and that means you'll have more context switches, and that again makes it harder to work to focus on your actual coding job. So yeah, we have all these haphazard integrations, trying to keep parts together, but it's all not that coherent. So I've been working on trying to tie these loose ends of tooling together. By the way, a hobby of mine is knots. So just the other day, I taught somebody to tie their shoelaces. So if you want to learn a new way of tying your shoelaces, talk to me later. Anyway, yeah, tying tooling. I want to create a more integrated development experience. So in that regard, let's have a look at some prior art. So one popular approach has been the language server protocol, which addresses this major integration bottleneck, specifically between editor and compiler. By the way, who's heard of the language server protocol so far? Yeah, that's increasingly many people. It's a protocol developed by Microsoft for the Visual Studio Code editor, where you'll have a language server implementation for a specific language. That's basically kind of a compiler front end. And you'll have the editor side, and the editor just asks the language server to give information about the code or to do operations on the code. That's in contrast to what we've been doing with IntelliJ so far. Namely, we write a language-specific implementation in IntelliJ, which runs inside IntelliJ. And yeah, this approach doesn't scale as well for new languages, especially languages that don't have any big traction yet. So it's hard to build a new plugin for a specific language. This is what the language server protocol makes easier. Now, it has been quite successful, like so successful, people keep asking us, hey, will you use LSP to support Scala in IntelliJ in the future, especially with Scala 3, where the only IDE sort of support is based on VS Code and LSP. And actually, we've looked into this recently, so I think we might be offering this as a way of supporting Scala 3, at least initially, because it means we won't have to implement the whole Scala syntax and type checker on our end. But this does come with drawbacks, namely a lot of the IntelliJ features are based on our own implementation of the abstract syntax tree, especially refactorings, and also more rich type error highlighting. So that there's advantages and drawbacks to these approaches. Some of the challenges of integrating LSP is with an IDE, specifically IntelliJ, is, LSP does not model the structure of the code base, and some of our refactorings take advantage of knowledge of the structure. So like modules, dependencies between modules. There's no real common concept of building or testing or running in LSP. So it's only kind of implicit. So you save the code, you may want to do another build. It's not a huge impediment, but it's a bit of a difference as to how IntelliJ works. In IntelliJ, you expect to be able to run a full build or even rebuild or just an incremental build. And as I mentioned, the syntax tree is LSP doesn't have a concept of a syntax tree in the protocol. Anyway, I mentioned build tools. So every so often there comes a new build tool. Well, Fury has been emerging for months now, but it doesn't really have a user base yet, aside from the developers. Nonetheless, I'd like to be able to support it in IntelliJ. Now, I can't replicate the effort I've put into SBT, but and well, maybe the build tool author is John here. Anyway, John is somewhere around here. Maybe the build tool author wants to write IntelliJ support in some fashion. Or maybe not, because the author never uses an IDE. But the users of the tool often do want to use an IDE. And at least I do. So nonetheless, I'm gonna go ahead and open an IDE now, which for some reason hasn't been started. Put this over here. So you might see already I've got Fury ready here. And I actually have it already imported into IntelliJ. And you can see the project structure. So here, for instance, I have the BSP implementation in Fury. So what I did is I implemented BSP into Fury, and I have an implementation of BSP in IntelliJ. And this allows me to simply open and work with any code base that is built by a build tool that supports BSP. Now, of course, that seems pretty straightforward, and there might be some, yeah, I get a good leverage out of that. But so implementing build tool support in IntelliJ can take anywhere from a few days to a few weeks to a few months or years, and still fixing bugs in the SBT implementation. But I heard some nice quote, maybe by Abraham Lincoln: "Give me 6 hours to fell a tree, and I will spend 4 hours sharpening the axe." And I was inspired and thought, yeah, give me 2 weeks to support a build tool, and I will spend the first year implementing a protocol. Now, as an aside, Fury isn't only a BSP server, which means IntelliJ can connect to it and import projects. It's also a BSP client relative to Bloop. So if you haven't heard of Bloop, it's not quite a build tool. It's more of a compile server. So the idea is you have resident tool that runs the Scala compiler for you. And unlike in SBT or Fury, it will keep, well, sorry, not Fury. Unlike in SBT, if you run SBT compile from the command line, that starts a new compiler, but the JVM performance and thus the Scala compiler performance is heavily dependent on the just-in-time compilation and optimization. And Bloop takes advantage of this by offering a resident compiler, besides various other optimizations specific to the Scala compiler. So Fury takes advantage of Bloop by connecting to it over BSP, because Bloop is another implementation of the build server protocol as a server. So Fury simply delegates the compilation to Bloop. Now that's a use case. Now I'll go into a bit of how BSP looks like. So I mentioned LSP, language server protocol. Build server protocol sounds very similar. It is very similar. It basically extends and complements the language server protocol. But rather than integrating language servers with editors, it tries to integrate build tools, build servers with editors or language servers. That's actually the approach taken by Metals, if you've heard of it. Metals is a LSP language server, but it is a BSP client relative to Bloop, just like Fury. Whereas IntelliJ is both editor and language server, if you will, in one. So BSP conceptually abstracts the project model that is common to most build tools into a few generic concepts and defines a few common operations that you can do on this project model, such as compile, test. Now, just like LSP, it's a client-server protocol, but there's not only the client can send requests to the server and the server answers, that's the typical case, but also the server may send requests to the client answers likewise. But more typically, the client sends requests and the server sends answers or notifications, which are not attached to any specific request, or at least not necessarily. Notifications just go one way, don't expect an answer. But so we have a way for client and server to talk to each other, but we'd like them to be able to find each other. For that, we added the concept of server discovery. It's really a simple protocol. When you install a build server, like Fury, and generate a project, then the build server will place a server connection file, that's just a JSON, that describes how to start a server process. And the client, if you want to open this project, just looks for this connection file and starts the server process. And it will communicate with the server process simply over standard in, standard out. In the behind the scenes, the server may simply the server may run the actual server code directly in this process, or it might connect to a server over some other protocol, TCP for instance, and that might even be a remote server, remote compile server. Now, once the client has found the server, there will be a few lifecycle requests. So like the client will just send to the server, hey, build initialize. That's what the request is called. And the server eventually tells the client, yeah, I'm initialized. Then the interesting stuff happens. And at some point there will be a build shutdown request and a build exit request, which just tells the server to just go dead now, please. Now, interesting part. Modeling the build structure. Essentially, most build tools will model a build structure by a directed acyclic graph between various modules or projects or targets. So in SPT it's called projects, in IntelliJ it's called modules, in Bazel it's called targets. So the BSP project model follows Bazel very closely. So we call it targets. And a target is a bunch of sources, and they have some associated metadata such as capabilities. Can you compile it? Can you test it? Some language-specific data like JVM or Scala SDK, and dependencies on other modules, other targets. So there's a single request to get all the targets in a build or in a workspace. And there's a different request to resolve all the sources in a set of targets. And in BSP, one module may have a bunch of sources in different files or directories, and these sources might be shared between different modules, different targets. Next part is build actions. So I mentioned compiling, testing, running. We've defined standard requests just for compile, test, run. And they do exactly what you'd expect them to do. You compile a set of targets. So typically in BSP you define which targets specifically want to compile or test or run, and the server will then hopefully do this. During such a request, server might send a bunch of diagnostics or progress notifications. I'll get to that in a second. And eventually it will return a compile result. Now, diagnostics is a concept that looks just like in LSP. It's just your messages of the compile. It's like a warning, an error, a code location, typically associated with a code location, but not necessarily so. Tasks is a concept we added to BSP over LSP. So tasks and progress notifications tell you when there's a long-running thing happening. The server might send a task start notification, and during the build, typically, it will send task progress notifications that say, okay, I've compiled 100 files, 1,000 files. I'm 67% done. And eventually a task done notification. These tasks can be structured as groups, like they can be hierarchical. A task can have several subtasks. And they might also be sent independent from any requests. So the server could be telling you, hey, I'm doing some indexing in the background. Let's have a quick look at IntelliJ, at how this looks in IntelliJ. So, nope, no, that's the wrong one. So here's Akka, for instance. I imported Akka. Akka is usually an SBT project, but I exported it to the Bloop model and imported it into IntelliJ via Bloop. And build failed, great, just great. I'll try to do a refresh and hope that works. It looks like it might not be working. No, it did work. Now I should be able to do a compile, okay, and you see what's happening. You're getting a lot of nice check marks. So this is, we have a whole bunch of modules in Akka that have already been compiled. So Bloop will immediately say, okay, I compiled this. And you get a nice timing for each module. And you'll get an output of diagnostics, so warnings, and you can navigate to them straightforwardly. So that was fairly quick. Well, still took 28 seconds to compile. Maybe there was something that wasn't quite yet compiled. And actually, we already have BSP support in Mill. We have an open pull request on that. Mill is yet another build tool in case you didn't know. Let's see what happens when I do a compile here. It opens this build tool window and it shows build running, and you'll see some usual process output. It doesn't send any notification yet, but I'm sure that's coming up in shortly, or not. Well, that's unfortunate. Yeah, the integration isn't perfect yet, maybe. Let's try Akka again. I just cleaned the output. And that's going to take a while, so why don't we... Oh yeah, you see now, here you're getting progress notifications. Akka actor is at 10% after 12 seconds. So this helps you find out what modules are taking forever to compile, where are your actual bottlenecks, versus the usual IntelliJ or SBT compile where you just have a whole lot of stuff happening in the background and you don't have a fine-grained view on it. So I'll get back to my presentation for now. So the BSP support in the IntelliJ plugin for Scala is an official feature since the latest 2.19.2 release. So most of the time it should work. If not, I'm happy to hear of your issues. Currently it only supports Scala targets, but we're planning to improve and broaden the scope so that you can import languages for more build tools in different languages. Now, a bit of specific of the challenges in integrating this into IntelliJ. Now, build tools often have a fairly flexible model that is reflected in BSP, so you can have shared sources between various targets. And some have more specific models and assumptions, such as SBT by default defines a compile scope and a test scope for each project or sub-project. And BSP doesn't have scopes, it just has targets. So if we want to map a SBT project to BSP, what we do is create separate targets for the compile and for the test scope and dependencies between them. And IntelliJ has another problem. IntelliJ does have scopes, but only for compile and test, not for integration test or any made-up scope that you can have in SPT. But a limitation of the IntelliJ project model is that a set of sources can only be associated with one module exactly. So that's always been a challenge in importing SPT projects, because if you have multi-platform projects, they typically will have shared sources between different target platforms. So our workaround is to create a shared source module. So if we detect that there's sources shared between specific targets, we create a new module, put all the shared sources in that, and define a dependency from the modules that share these sources onto that module. That kind of works, but if you use the IntelliJ project model compiler, then you'll probably get compile errors in either one or the other. So that's basically a case where you have to outsource the compiling to an external build tool. And luckily, BSP does this by default. So we have a little less trouble there, but you might still get highlighting errors and other such issues. It's not great, but we're working on ways to address this. Maybe by allowing context switch in a specific module. I've already shown you how the compile requests look. Let's have another quick look at Akka here. Okay, it compiled by now. Everything took 3 minutes, 18 seconds, and yeah, you can see which modules took long. So Akka actor took 45 seconds, Akka stream 54 seconds, and so on. And a lot more warning messages. Luckily, no compile errors. But you would see them in here as well. Now, a quick overview over the BSP ecosystem. So we've got a lot of nice lines here. So I've focused, of course, on IntelliJ, which is a BSP client relative to all the servers. And the other client is Metals. Metals by default works together with Bloop. So you can use Fury or Bloop directly with IntelliJ, and also in this branch where we have an open pull request with Mill. The other Scala build tools don't have a direct BSP implementation at this point, but they allow exporting to Bloop. So if you think working with Bloop is the most efficient for you, then you can export their project model to Bloop. There's plugins for them, and then import the Bloop project into IntelliJ. On our roadmap is, so all the implementations I showed you now work with protocol version 2.0. We had a 1.0 last year, which was more or less the development iteration. 2.0 we expect to be pretty much stable. We have IntelliJ, Bloop, Fury, Mill. The goal is, of course, to support more build tools directly. My hope is that we can support SPT soon, which will hopefully enable a smoother integration with SPT, because I've been working on that for a while, and I'm not very happy with the IntelliJ Scala SPT integration, because it depends a lot on working with the SPT process directly, parsing the shell output, and such hackery. And of course, more complete support for more languages Now, the title of the talk did have the "and beyond," so I'm not going to go far beyond, but if this concept is successful at all, it might be a model or impetus to expand the scope of the protocol or create new protocols maybe. So we can think of how we integrate other tools that we typically run from command line or CI server only in a way that seamlessly integrates with an IDE. So one example would be linting. Can we integrate linting tools that we usually run in a build tool into a kind of a BSP pipeline? Remote building would be very interesting because some people develop on low-powered laptops, but they want to run tests and compiles without heating the room. And yeah, BSP already has pretty good support for reporting tests, but maybe there's a more fine-grained way of doing this in a way that transfers to various other tools. Naturally, there's some challenges associated with establishing a protocol. So not all tools are so similar that you can just switch them out and just implement a protocol on top and run them exchangeably. That's one consideration, but the main consideration is adoption. And that's the reason I'm speaking here to you now. I want to improve the adoption of the build server protocol by making you aware of it and hopefully inspiring you to either use it or even implement it for your favorite build tool. Now in this slides I got a few links. There's the link to the specification, to implementation of libraries BSP4J, which includes a test kit, and a whole blog post that I wrote recently on the IntelliJ Scala plugin blog. So that concludes my presentation, and I'm happy to take questions or comments, or if you don't want to speak to me directly, you can message me on Twitter, but please feel free to speak to me directly right here. That's my Twitter up here, Ebenbelt, and the Scala plugin team also has a Twitter, IntelliJ Scala. Yeah, question? Mm-hmm. Why isn't Bloop enough as a integration point? So Bloop is just a compile server, but full build tool does other things as well, such as generating sources, packaging, and so on. So, and if you want to integrate all of these in your workflow, then working just with Bloop directly will miss out when you will not do this if you do a compile request. That's also been a challenge with the SPT integration, because up to the point where we integrated the SPT shell with IntelliJ, we had the issue of we could import projects and build them, so the compiling worked fine, but if you had any other steps in your build process, such as generating sources, this would not work. And you'll have the same issue if you work with Bloop. Any other comments? Yeah?
Just
Mike's incoming.
You said that BSP is language agnostic. Are you aware of any work on BSP support in other languages?
At the moment, no, I'm not. So we're trying to get the traction in Scala going and see how it works with other languages. But there is some work getting it working in Pants, which is a build tool by Twitter, and they use it to build different languages besides Scala. So that would be a good starting point. More comments? Yes.
Hi. I wanted to ask, so when you shown the integration with Bloop in IDEA, you had this nice panel with times, and it's sort of shown the dependencies between the projects, just like you have to look at the runtime and like you see that it compiles first and this compiles second.
The way it's implemented, it doesn't show the dependencies, but in principle it could if Bloop reported these tasks as subtasks of another. That would be possible, yeah.
My question is, I'm not sure, but is the same stuff available for just the normal Scala SBT integration in IDEA, or
no, not at the moment. So the SBT integration specifically is just based on the SBT shell. So we parse the shell output and or just use it to determine is a task running or not. And that doesn't work that greatly, but so one plan is to support BSP in SBT, and with that you'll have a better interface integration as well.
So when do you think it will be available?
I can't commit to anything yet.
2 years. Okay, no, thank you.
It depends on if somebody wants to take the initiative to do it, or if I have to wait for my time to free up to do it.
Thank you.
But Eugene Yokoda, the maintainer of SBT, has at least shown some interest. Anyone else? Okay then. Thank you all for your attention.